All right, 5.2 today is direct variation. A direct variation equation has some special qualities to it. A direct variation equation always is written in the form y equals kx. And k just represents a constant. It's what we call a constant of variation. Okay, so if it's a direct variation, it's always written in this form. There's nothing added to the end of it. A direct variation always crosses through the origin. And a direct variation, to find that k value, we can always find k. Whoops, helps if I write correctly. Find k by taking y and dividing by x. All right, so the homework today is split into 3 sections. So I want to talk about the first section first. Makes sense, right? In the first section, move that up just a little bit. Example number 1. This is going to cover, oops, I got to get on the right page. This covers problems 9 through 14. It wants to know if the linear equation is a direct variation and if so, state k. All right. So over on the side next to this example, here's what I want you to put. Over here, the first thing you have to do is get y by itself. Step 2, compare to y equals kx. If they're both in that same form, state k. Seems pretty straightforward, right? All right, so we're going to start with a really easy one first. I'm going to do about 4 of them all in this example so you can see them. Okay, so first thing, let's say I have y plus 2x equals 0. The very first step tells you to get y by itself. So what do I have to do with that 2x? Subtract it to the other side. I agree. Minus 2x to both sides. So now we have y equals negative 2x. All right, y is by itself, so we're done with step 1. Step 2, compare it to y equals kx. Is that in the form y equals kx? Yes. So we say yes, and then we state what k is. What is k? -2. Perfect. That's it. All right, let's do another one. I'm going to keep it all kind of under the same example because it's all part of the same group. What if I have 3y equals 7x? Divide by 3. Whatever I do to one side, I got to do to the other, right? So we get y equals 7 over 3x. Is this a direct variation? Yes. And what is k? Yeah, 7 over 3. You got to have the whole thing that's in front of x. Okay? Let's do another one. Let's say I have 2y equals 4x minus 6. Divide by 2, and if I divide this side by 2, I have to divide everything by 2, right? Okay, so that gives us y equals 4 divided by 2 is 2x. minus 3. Is this in the form y equals kx? No. So you just say no. That's it. That's the first third of your homework. You guys want another example of this? The real key is working on your algebra skills and getting y by itself. Okay? Okay. Let's move to the next part then. In the next section, out of the 3 sections, it's probably the hardest one, but it's not hard. Okay? In the next section, so this example number 2 is going to cover your problems 15 through 20. All right. And the directions are going to say, suppose y varies directly with x, and y equals 8 when x equals 2. Find y when x equals 7. Let me kind of fix this. Now, here's the steps we're going to do. Okay? Again, got to trust me. Step 1, I want you to find k. Now, remember to find k, we're going to take our first line of work right here, and it is y divided by x. Okay? Second step, after we find our k, I want you to write y equals kx. Step 3, solve for the unknown. All right. So step number 1, we've got to find k. So we're going to use this first line of work we have here, our first line of information. We have y equals 8 when x equals 2. So we got to find k. K equals y over x. What does k equal? Which is what? 4. Thank you. All right. So that's step 1. Step 2. You write the direct variation equation. Y equals 4x. Step 3 is where you go to that last line right there. It says find y when x equals 7. So what do you think I'm going to do with the 7? Plug it in and solve for the unknown. So I have y equals 4 times 7. So what does y equal? What is it? 28. Sounds good. So again, it's only 3 steps, and none of those 3 steps are hard. Okay? So let's do another one. Still underneath the same example because it's the same type of thing. How about this time I tell you y equals 9 when x equals negative 3. Find y when x equals 12. So what is the very first thing we're going to do, you guys? K. So we're going to use that top line to find k. K equals 9 over negative 3. So k equals what? Negative 3. Good. Second step, we write our equation. Y equals negative 3x. Third step, we're going to plug 12 in for x. Y equals negative 3 times 12. Y equals negative 36. That I agree with. All right. Not too bad, right? Let me do one more example. Because again, as I said, this is the hardest section out of the 3. And you guys think this is good? Right? Okay. One more. Let's make it a little harder, though. Are we good with harder? Good. How about let's do y equals, let's do something like this. 10.2 when x equals 4. Find y when x equals 12. Oops. That's supposed to be n equals 12. All right, so what's the first thing we're going to do? K equals 10.2 divided by 4. And since it's already a decimal, we're going to put our answer as a decimal. So go ahead, grab your calculator, type in 10.2 divided by 4. Thank you. All right. Now we're going to write our equation. Y equals 2.55x. And what is the very last thing we do? Plug in what? 12 for what? X. Very good. So y equals 2.55 times 12. Thank you. Awesome. It doesn't seem too hard, right? Good deal. All right. Ready to move to the last section? Yeah, this is the hardest section on all three. Once you figure out how it works, right? Exactly. It's just a simple formula. All right, last section. In the last section, we are going to graph the direct variation. Now remember, one of the special things I told you about it was that it crosses through the origin. So here are the steps I want you to do. First step is I want you to plot or put a dot at the origin. Step 2, I want you to move rise over run for your K. So you know how your K is always y over x? That's now your rise over run. Put a dot. Then step 3, we're going to connect. All right? So here's example number 3, which again covers the rest of your homework, which is 21 through 24. All right, the directions are simply going to say graph. And let's do y equals 2 over 5x. That's a direct variation, right? First thing we do is we put a dot at the origin. It's right here in the middle. Then our K value is what? What's K? 2 over 5, right? This is our K value. Wrong way. Rise over run. Yes. So from here, we're going to go up 2, and we're always going to run to the right. 1, 2, 3, 4, 5, and put a dot. And then we connect. That's it. So let's do another one. How about if we graph y equals negative 1/3 x? So where do we put our first dot, Corbin? Thank you. We start at the origin with our first dot. Thank you, Ian. Now, we do rise over run, but we have to go down because it's negative, right? So we're going to go down 1, and how many am I running to the right? 1, 2, 3. Put my dot. Connect my dots. Oh, great question. Here's my last one then. Let's do y equals 3x. Okay, so first thing we do is we put a dot at the origin. Whoops, helps if I make that not quite so sloppy. All right, now, let's talk about this. Our K is 3. Corbin, our K is 3. What magical number is always underneath there? A 1, right? So I'm going to write it as 3 over 1. So now tell me, how many am I going to rise up? 1, 2, 3. How many am I going to run to the right? 1, and put my dot. There's always a magical 1 underneath it. There you go. Did that answer your question? Good. All right. Yeah. Yes, there is. Okay, so what I'd really like to see, I think you guys can probably get this done in like 10 minutes at the most, which means you'll be done before the end of class. Oh, yeah. Okay, so I'd like to see you get started right away. We are doing 9 through 24 all. Okay, I want to remind you that I gave you all. I know I gave you all. That means the odds are in the back if you want to compare and make sure you're doing it right. Okay? That's a good idea. I think so. Oh, I only talked for 15